In this video, I will be discussing the major steps and history of constructing my Stirling engine. I will discuss some of the particular challenges and solutions I adopted throughout the building process, and I will make some suggestions on how I improved my design and how I would build it differently next time. One of the major steps in building the Stirling engine involves creating the displacer, which I found to be time-consuming and required accuracy. The next major step in building the engine requires cutting the various pieces of the Stirling engine out from the can. I found that using a sharp X-Acto blade to rough cut the pieces and then finish them with scissors produced the cleanest and most effective results. Another major step is the creation of the crankshaft, which I utilized a table vise in order to create. I also used the vise to help straighten wire and various connecting rods and to make bends throughout the construction. After analyzing potential faults with the first Stirling engine, it appears that it failed because the displacer pin I used was too large, failing to provide an airtight seal in the top chamber. I also used too large of a machine screw inside the balloon diaphragm, adding unneeded weight and friction. As well as fixing the obvious faults with the engine, I wanted to adjust the next design of my Stirling engine in a way which would allow for adjustments and troubleshooting if necessary. So on the second version of my Stirling engine, I replaced the sewing pin used as the displacer connecting rod with fishing line. This greatly reduced the diameter of the hole inside the pressure vessel top, allowing the engine to maintain an airtight seal. Next, I replaced the fixed size connecting rod from the crankshaft to the displacer with an adjustable connecting rod. I added a kink to the rod, which would allow for adjustment to the height of the displacer piston. I also would attach the 3/4 inch PVC elbow using 3M double-sided tape instead of epoxy for a quick and accurate installation. I incorporated the pressure vessel top and crankshaft supports into one unit by using a 12-ounce standard soda can with a viewing hole cut through the side, and by carefully seating the pressure vessel top inside the pressure vessel bottom. I did not need to use silicone sealant to achieve an airtight seal. This also allowed me to be able to disassemble the vessels if troubleshooting was required. To help balance the rotating assembly, I added a counterweight to the flywheel by taping a small washer to the CD disc. After making these various adjustments, I ended up with a running engine.